Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 6, our video on the chapter of compound interest, where I will discuss about some applications of compound interest in the real life scenario, uh, like growth and decrease of population, bacteria count and the cost of articles. If you have not watched the previous 5 videos on the chapter of compound interest, I strongly suggest and request that you watch those videos also to maintain the continuity of your study on the chapter of compound interest. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the right hand side. Uh, so this is in this video I will discuss about how the idea of compound interest is used in uh, in the real life scenarios. So the real life scenarios are growth of population, growth of bacteria count, and depreciation of values of articles are all based on compounded rate of interest. So all these are the growth of population, the growth of bacteria count, and depreciation of values of articles. These are fundamentally based on two things. The first is the growth or increase formula based on the compound interest, and the second one is the decrease or depreciation formula based on the compound interest. So the growth formula for based on compound interest is A equals to P multiplied by 1 plus R by 100 to the power n, where P is the original value. Now this original value could be the population, it could be the count of bacteria, or it could be the cost of an article. And A is the final value after a period of n, and R is the rate of growth. Since this is the formula for growth or increase of some quantity, R is the rate of growth. Now this rate of growth could be per annum regarding it is per annum for population or cost of articles, and it could be per hour for the growth of bacteria. So this rate will depend on the real life scenario, and n is the period of time. So for population and cost of articles, it is usually in years, and for bacteria count, it could be in hours. Okay, so this is the fundamental formula of growth or increase of a quantity based on based on compound interest. That is, the rate of interest is compounding. Similarly, the decrease or depreciation formula is A equals to P multiplied by 1 minus R by 100 to the power n. Instead of plus, we are having minus. So as usual, P is the initial value, A is the value after period of time n, and R is the rate of depreciation. As for the growth or increase formula, the rate could be in per annum, or it could be in hours. Like for population or cost of articles, it is usually in per annum. But for the growth of bacteria, this could be in it could be in hours. And so P is the original value, R is the rate of depreciation, and n is the period of time. So these are the two fundamental formulas that will be used to calculate to solve problems, real life problems based on population, bacteria count, or cost of values, which are based on compound interest. Now, these two formulas can be extended a little further, where uh, where a certain where a certain quantity is growing and also decreasing with different rates over successive period of time. For example, this formula, let's say there is a quantity, there is a certain quantity is uh, let's say the nature of growth or depreciation of a certain quantity is that in the first in the first period. Now this period, in the by first period I mean this period could be 1 year or it could be an hour. So in the first period, the quantity is growing at the rate of R1. In the second period, the quantity is decreasing, that is depreciating at the rate of R2. And in the third period, the quantity is again growing at the rate of R3. Then the final value after 3 period of time will be P multiplied by 1 plus R1 by 100 multiplied by 1 minus R2 by 100 multiplied by 1 plus R3 by 100, where P is the initial value of the quantity. So this is an extended formula based on the two fundamental formulas of growth or increase and decrease or depreciation. Okay, so these are the fundamental formulas that will be required to solve problems which are applications of compound interest. Okay, now let's try to solve as an example problems. Let's try to solve three problems. So the first problem says, I will quickly check whether everything is visible or not. Okay, so the first problem says that the price value of the share of a company increased at the rate of 20% in a year and decreased at the rate of 10% in the next year. So here the quantity is the value of a share, that is the price value of a share of a company, which is its behavior is that it is increasing at the rate of 20% per annum in a year. In the first year it is decreasing at the rate of 20%, and in the second year, that is in the next year, it is decreasing at the rate of 10%. So if the present value of the share is rupees 1000, then what will be its value after 2 years? So definitely we will apply the extended formula. We will apply the extended formula. So we will have A is equal to, that is the final value after that is the A will be the price value of the share after 2 years, will be equal to the price value of the share currently, that is the present value of the share, multiplied by 1 plus uh, 1 plus the rate of increase in the first year, which is 20 by 100, and then multiplied by 1 minus the rate of decrease in the next year, that is 10 by 100. So basically we applied the formula. A is equal to P multiplied by 1 plus R1 by 100 multiplied by 1 minus R2 by 100, where the quantity is increasing at the rate R1 in the first period and it is decreasing at the rate R2 in the next period. Okay, so this will be P multiplied by 1 plus 20 by 100 is 1 by 5, and this is 1 minus 10 by 100 is 1 by 10. This is equal to P 1 plus 1 by 5 is 6 by 5 multiplied by 1 minus 1 by 10 is 9 by 10. So this is equal to P is given to be 1000 multiplied by 6 by 5 multiplied by 9 by 10. Okay. So 0 0 cancels out and 5 or 20. So this is equal to 120 multiplied by 9. This is equal to 0, 18, 10. So uh, the price value, the price value of the share after 2 years will be 1080. I will quickly, this is a problem taken from some reference book. I will quickly check whether the answer is correct or not. uh, so the price value of the share, yeah, it is correct. So this is how, so this was an example where the quantity or the value is decreasing or growing over successive periods with different rates. Okay. Let's solve the next problem. In a certain experiment, the count of bacteria was increasing at the rate of 2.5% per hour. So as you can see in this example, regarding the growth of bacteria, the rate of growth is given as 2.5% per hour. Initially the count was 512,000. Find the bacteria at the end of 2 hours. Okay. So what we can see is that the initial value, so we will apply the formula of the growth or increase of bacteria count based on the compound interest, which will be A is equal to P. P is the initial count of the bacteria multiplied by 1 plus R is the rate of growth. In this case, regarding bacteria count, this is a percentage per hour. This whole raised to the power the period, the number of periods. In this case, in this example, it is 2 hours. The period is given as 2 hours. Since it is asking to find the bacteria at the end of 2 hours, that is for 2 hours means the period is 2 hours. Okay. And so A will be the bacteria count at the end of 2 hours. P is the initial count of bacteria, and R is the rate of growth of bacteria count per hour, and N is the total time period, which is given to be 2 hours. So we have P is 5, 1, 2, 000. This multiplied by 1 plus R is 2.5 divided by 100 to the power 2. Okay. This is equal to 5, 1, 2, 000 multiplied by 2.5. 2.5 is, this is 25 by 1000 is square. This is equal to 512,000 multiplied by 25 by 1000 is 1 by 40 square. This is equal to 512,000 multiplied by 1 plus 1 by 40 is 41 by 40, this square. So this is equal to 512,000 multiplied by 41 multiplied by 41 divided by 40 multiplied by 40. Now we have to simplify this value. 20 cancels out, and I guess 16 to the power let's divide 4. 512 is 1, 2, 8 and 4 again divides 128 with 32. So this is equal to 41 square multiplied by 32, and to do the calculation I'm using calculator. I'm really sorry for this, but you should be used to do all this kind of calculation with hand yourself. So 41 multiplied by 41 is this, multiplied by 32 is 5043. So this is the count of bacteria after 2 hours. So this problem is an example problem from the textbook of author R.S. Aggarwal only. Let me quickly check whether the answer is correct or not. No. 512000. My answer is incorrect. So I might have done something wrong in the calculation. So it is 41 by 40, 2.5 per hour. Okay, 2.5 by 100. Fine. 2.5 by 100 is 25 by 1000, which is 1 by 40. 1 plus 1 by 40 is 41 by 40. So 41 by 40 square is 512000 multiplied by 41 multiplied by 41 divided by 40 multiplied by 40. So 20 cancels out. Okay, so there will be a 0 over here. So this is 41 square multiplied. I will again use the calculator. This is 41 square. 41 multiplied by 41 is this, multiplied by 320 is 537. 5 3. My machine is running very slow. 537920. I hope this time the answer is correct. Let me quickly check. 537920 is the correct answer. Okay. So this was an example of how to use the growth or increase formula based on compound interest, applying to the real life scenario of a growth of a bacteria count. So as you can see in this example, regarding the growth of bacteria, the rate is given 2.5% per hour, and also the duration, the time period also is given in hours. Now instead of hours, it could be minutes or even seconds. Okay, let's see the next problem. This is regarding the population. So it says that the population of a city increases at the rate of 4% per annum. Find the population of the city in the year 2007 if its population in 2005 was 62500. So this is regarding increase of growth of population based on compound interest. So the formula will be similar to the formula used will be for growth or increase of any of a population based on compound interest. So if P is the initial population and the population is increasing at the rate of R per annum, then the population after n years will be if that is A, then A is equal to P into 1 plus R by 100 to the power n. P is the initial population, R is the rate of increase of population per annum, and n is the time period. That is for how many, after how many years we are trying to find the population. That is A is the population after n years. So in this problem, we have to find the population of the city in the year 2007 if its population in 2005 was 62500. So that means if the current population is 62500, we have to find its population after 2 years, because 2007 is 2 years after 2005. So we have P is 62500. This multiplied by 1 plus R is 4. So 4 by 100, and in the period of time is 2 years, because from 2005 to 2007 there are there are 2 years. So 2, this is equal to 62500 multiplied by 4 by 100 is 1 by 25 square. This is equal to 62500 multiplied by 1 plus 1 by 25 is 26 by 25 square. This is equal to 62500 multiplied by 26 divided by 25 multiplied by 25. Now 25 multiplied by 25 is equal to 625. So this cancels this with 100. So this is equal to 26 square multiplied by 100. This is equal to, how much is 26 square? 36, 15, 5. This is 6, 7, 6. 6, 7, 6, 0, 0 should be the population in 2007. This problem is from another reference book. Let me see if the answer is correct or not. Increases. Okay. So I just the problem is not exactly from in the reference book. In the reference book, it was given the population is decreasing, but I have changed that to the population of a city increases. So anyway, I hope the calculation is correct, but there could be some mistake in calculation. I am not really focusing in that. So I hope with these three problems you got an idea how to use the application of compound interest to solve these kind of problems. So essentially solving problems based on growth of population or growth of bacteria count or the depreciation of values, that the depreciation of cost of any value are fundamentally based on these two formula, that is the growth increase formula based on compound interest and decrease and depreciation formula based on compound interest. Now and also the extended formula, that is if there is a growth or depreciation of the quantity with different rates over successive period of time. Now in this extended formula, this extended formula is for the scenario where the quantity is growing. In the first period, the quantity is growing at the rate of R1. In the second period, the quantity is decreasing at the rate of R2, and again in the third period, the quantity is increasing at the rate of R3. Now this increasing and decreasing, it could be anything. If it was if in the second period it was increasing, then obviously it would have been 1 plus R2 by 100. I hope you got the idea, and this formula could be extended over any number of periods with given rates of either growth or depreciation. So I hope I was able to explain the fundamental formulas regarding the applications of compound interest for real life scenarios like growth of population or growth of count of bacteria or the depreciation of values of particles with some illustrative examples. So if this video was beneficial, then please like it, share it with your friends, and also support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think I have covered all the theoretical part on the chapter of compound interest from the textbook of author R.S. Aggarwal. Now I will keep on solving the problems from the exercise. Let me quickly check which are the exercise that I need to solve from the textbook. Uh, I have solved problems up to exercise 11A. So in the subsequent problems videos, I will solve the problems of exercise 11B, and then I will solve the problems of exercise 11D, which is objective questions, and then finally I will solve the test paper 11. Now the problems of exercise, the objective questions, there are 15 questions in the objective questions exercise 11D that I will cover in one video, and also the test paper 11 has roughly 11 questions. I will also cover that in one video, but exercise 11B has a lot of questions. There are 30 questions, so probably I will take 3 videos to solve all the problems of all the 30 problems of exercise 11B. So please stay tuned for all the upcoming videos where I will do a lot of solving problems on the chapter of compound interest. So that is all for this video. Thanks for watching, and until the next video, take care and bye.